So hello friends, today we are going to discuss about NPSH and its importance for cavitation. So let us start. So content introduction is today we are going to discuss about introduction to NPSH, NPSH formula, NPSH positive suction head with example, NPSH negative suction head with example, cavitation its impact, real world application or example. So finally conclusion. So first of all, definition. So net positive suction head is a measure of pressure available at suction side of a pump to ensure the liquid being pumped does not vaporize. That means does not reaching its boiling point due to low pressure, which would cause cavitation. So basically it is two types. So first one is net positive suction head available, and it is the actual pressure head at the pump suction calculated based on the system. Second one is net positive suction head required. The minimum pressure head required by the pump to avoid cavitation as specified by the manufacturer. Okay. Next is the component or formula of NPSH. So okay, NPSH available formula is HS, HA, HV. So what is HS? HS is the suction head from pump center line to the, or it may you can say that it is the static head. It is measured from the pump center line to the top of liquid surface. HA is the atmospheric pressure. Atmospheric pressure exerted on the water surface, which is basically 10.3 meter in water column. Okay. And HV is the vapor pressure. Basically, water vapor exerts some pressure on its surface is called vapor pressure. Final is the head loss due to friction or bend. This one you can see there is a bend or some friction in pipeline, okay, which is called as HF. Finally you can see that key consideration for safe operation of a pump, NPSH available always greater than required. Okay. Net positive suction head in positive head pump. So next topic is, in this you can see that liquid source above pump center line. In this image you can see that this is the liquid tank which is above pump center line. Okay, this is the pump center line. Second is the gravity assisted suction increasing pressure. By gravity water flow inside the pump. Okay. Suction head is positive, contributing to the net positive suction head available. If the water level is above center line, then HS is always positive. Okay. For this lower cavitation risk and easier priming. In this case, always cavitation risk is lower and priming is easily. Now let us consider with example or formula. Okay. HA, which is atmospheric pressure 10.3 meter. HS is the static head. This is the static head, which is 3 meter, and vapor pressure is the zero point 0.5, and friction loss due to head is 1.2 meter. So in positive head pump say kissan, net positive suction head available is the 10.3 plus 3 minus this. So finally this is the value you can calculate, 11.6 meter. In this image you can see this is the value of 11.6 meter, which is a net positive suction head available, and this is the net positive suction head required, which is specified by the manufacturer. It always less than available, or you can say that this is the value maybe 5 meter. Okay. NPSH required always specified by the manufacturer. Again I am repeating. Okay. And this is available. So next we are going to discuss about net positive suction head in negative head pump system. So in this you can see that liquid source below pump center line. This is the pump center line and liquid surface is the, this is called negative head pumping system. Pump creates vacuum to lift the pump. Static head is negative, reducing the NPSH. This is the static head. Okay. Fourth one is higher cavitation risk and difficult priming. And as compared to positive head, cavitation risk is negative pump is higher. Okay. Now let us understand with example. Same case also. This is the atmospheric pressure on water surface, and this is minus 2 meter. You can say that from some pump center line to this is minus 2 meter. Okay. Vapor pressure is same 0.5 meter, and friction losses due to head is friction loss in head is 1.5 meter. After calculation, the value is 6.3 meter. In this image, you can see that this is the net positive suction head available, which is 6.3 meter, and required is same 5 meter. So the basic difference between the negative head and positive head pump is NPSH available in negative head pump always less than positive head pump. Okay, but it must be greater than NPSH required. Okay, now move to the next slide. Next one is cavitation and its impact. So what is cavitation? Formation of vapor bubbles that collapse violently occurs when pressure falls below liquid vapor pressure. In this image, you can see that this is the formation of bubble. Formation of bubbles is also called cavitation. Now, what is the impact of cavitation? Causing pitting, vibration. Pitting means there is a erosion on impeller surface. Okay, noise, reduce pump efficiency. Okay, next slide. Now next is the real world application of pumps. For example, positive head pump. Positive head pump we are going to use in cooling tower pumps, chemical plants, tank transfer. Negative head pumps always sump pump, borewell pump, remote lifting pump. Or simply you can say that positive head pumps having always water level above from the pump center line, or negative head pump having water below center line. So final calculation is the ensure net positive suction head available always must be greater than required to prevent cavitation. Positive head pump system are safer and more efficient than negative head pump. In negative head pump system need careful design and maintenance. Consult pump curve and manufacturer data for NPSH required. Thanks for watching. Please like, share and subscribe for more knowledge.